Okay, hey everyone. I'm going to kick off as we are running behind the schedule. I hope you're doing fine. My name is Marcin. I'm co-founder and COO of RedStone Oracles and ETH Warsaw, which is a conference and a hackathon in Warsaw, Poland. Today I'm going to talk a little bit about KYC compliance and how oracles can play into that game, because usually oracles are in a different zone, right? So to kick it off, a few words about ourselves. RedStone raised $7 million last year from top Web3 VC. We as an oracle deliver not only price feeds, but also non-standard data. So as long as it is an integer, so like the result of the game or the election, for example, right now in Turkey, we are capable of providing that. Over here you can see lens score, so a score of a user on lens depending on his activity on the platform. We've been to over 30 conferences all around the world, gathering the feedback from developers all the time so that we create the technology that is useful for them, not that we are just thinking that is cool. And we are a team right now of 22 people dedicated to building and all the time hustling in the space. Funny enough, I just added this slide today because we had an interview with Tegan at the Defiant that was released just today. So if you are keen to learn more about the origins of RedStone, how everything works, and like what kind of models we have, please do check our Twitter. It's at redstone_DeFi, and you can check out the full interview with me and our founder, Jacob. So no further ado, what's an oracle for people that are not familiar? Oracles deliver various types of data on-chain for smart contracts and dApps. So how does it work in practice? So we have various data sources, we have an oracle, and we have various ecosystems on the other hand that need that data for various use cases. However, today it's 2023, not 2020 anymore, and the approach of oracles hasn't changed much since then. So it's a very simple way of putting data just on chain without doing any other legwork. But in order to create like a new financial system, we need to innovate, because currently the data feeds are very limited and within, let's say, 20 minutes or even 1 hour update interval, or sometimes even longer. So now ask yourself, and I suppose this is like the main slide to understand like what RedStone offers. Who requires data? Is it the chain, so L1 or L2, or a dApp? So you can quickly go to the conclusion that dApps require data for their smart contracts logic. So it's not that the blockchain is going to consume the data anyhow, it's just a cost. It's rather the startup that is using the data that is on blockchain. Then the follow-up question, can we deliver data to dApps omitting on-chain storage? And apparently we can deliver data to dApps directly, omitting the on-chain storage like almost up to the very end when it's necessary, like ultimately. Last but not least, okay, if some dApps are created that we cannot create like an on-demand, like they omit the on-chain storage, can we at least make it on-demand? And it turns out that if a dApp requires on-chain storage, we can still optimize the conditions upon which the data is delivered to chain, because currently it's mainly two factors. One is the heartbeat, so the interval between which the feed is updated, and the second is a deviation threshold, so specific percentage that the price feed differs from the last update, then updated again. So the main innovation of RedStone is RedStone Data Delivery Network. How does it work in practice? So we have data providers such as RedStone ourselves, but also Kaiko, Flow Traders, Bearing Waters, and other professional companies that deliver data feeds. And we have a data delivery network, which is an off-chain component that we created that is robust and resilient, that they send signed data packages to all the time. So you can imagine this like a kind of like a decentralized cache layer where the data floats all the time with the signatures of the data providers. And now we have 3 ways of delivering data to dApps directly. And now I'm going to talk about one which is on demand. So imagine Aave would use that flow. So Aave's frontend would fetch these signed data packages all the time. And when a user of Aave sends a transaction, imagine take a loan, then Aave would take the signed data package, the transaction of the user, combine the two by adding the data package to call data of the transaction, because on all EVMs we have always call data, and then deliver it to destination chain no matter what EVM it is, whether L1 or L2. And also right now we are extending outside of EVMs, so it can be consumed on Starknet, Fuel, Stacks, Aleph Zero, and soon on Ton networks as well. Ton network as well. Remember this slide because this is going to be important when I'm going to jump into the KYD Oracle. So just to show you the magic of cold data, this is from Ethereum white paper, and in every transaction on Ethereum you have from to value, and there is this data. Usually you store arguments over there, but you can also like store some payload, like this data package that we sign. How it looks on MetaMask. So if you're in a user and you're using this Aave that uses RedStone, if you go in MetaMask to hex, like section in your transaction, you're going to see that package. But from your UX perspective, it doesn't bother you. I mean, you can see it. Of course, everything is transparent, but it's not breaking the regular flow that you're doing within the dApp, which is beautiful. And now, there is no one solution fits it all. We created this off-chain component, and now we created also a couple of ways that we deliver data to the end customers. The first that I talked about is the on-demand model, which is best options for majority of DeFi and Web3 use cases as we see today, especially the ones that are created right now. So on ZK Sync, Polygon ZK EVM, and other very performant chains. Now, the second way of consuming data is based on our collaboration with GMX, which is called X model, and it's a front-running proof model where the transaction is recorded in one block and executed at the very next block, and in between the transaction and the data is joined together by relayers. So it's a kind of like a deferred execution model, you can call it. And last but not least is the classic Oracle model, where you can just take your regular Web3 application that uses chaining with other oracles, put it on other chain, and then use RedStone right away. So it's like this on-chain storage for dApps that find it difficult to adjust to either of the two previous. And this is not the end. Like, we created this data delivery network, right, this component, and depending on the feedback that we get from developers all the time on conferences, we can tweak it as we want, because this is off-chain. So it makes it way more customizable. The problem with on-chain storage and data is that it's super expensive, and it doesn't allow you to tweak that much, right? Okay, this is a bit more about the X model. I'm happy to talk about it more in private after the presentation. If you're building perps or options, this is the way to go. So for specific data like Ethereum, we have many sources, like here over 40. We also deliver like custom data feeds, so staked tokens, LP tokens, like for example GLP from GMX, gold, or even such, let's say, non-startup data as Russian losses of personal units. That was actually one of the Ukrainian developers creating a feed for the hackathon, right? So we just give the tool to developers, to the builders, and they can bring the data that they need for their use case. All right, and now to the meat. So, about Know Your DeFi oracles. The regulations will kill most of the protocols that we know today. This is a thesis. Unless they know how to protect themselves correctly. Tighter regulations are coming to crypto, and everyone feels that. For example, with Markets in Crypto Act, or MiCA, as we tend to call it, European Parliament voted in favor, and I want to also emphasize that it was one of the highest ratio of in favor of all the votings in the EU. So it was also a very important part for the European Union to regulate that. And actually, MiCA is considered quite favorable for the ecosystem over here, especially in comparison to the US. But what you can see is that the regulators see crypto and they want to start putting some restrictions and regulations in there. When it comes to traditional KYC, all of us probably has gone through it on centralized exchanges like Binance, Coinbase, and so on. It's expensive, sometimes 100 per user or even more, truly believe me. It's lengthy onboarding process, requires a lot of document checks. It's a frustrating experience, sometimes it doesn't go through, you have to spend minutes on that and so on. Hated by blockchain community in general. And now, how we can fix that? Okay, and also like there are thousands of interfaces that you have to fill in, right? So it's not like you do it once and then you can plug it to everything else. You have to do it again and again on any other application. What if we could use a different approach to that? Super lightweight for the dApp flow, so it doesn't break the UX of the user of the dApp, and completely invisible in the whole process. So here I present like KYD Oracle, which stands for Know Your Degen Oracle. It's automatic KYC firewall for your smart contract. So we are talking not on the Web2 KYC, but rather like a firewall on the smart contract level itself. So you remember this slide? Now, as I told you, in this data delivery network, we keep data packages, not price feed packages. So it can be other types of data too, right? So what if we had in this data package an information whether the specific user that interacts with the protocol can or cannot do the transaction at smart contract level. So it happens not after the execution is completed, because then the damage is done, but straight before the execution happens. And that's exactly how it works. So imagine you have a legitimate user that is interacting with Aave, and Aave, before executing the transaction, it would verify on a smart contract level whether this user is allowed to do, or if it's a restricted user. For example, you create a rule that every address that interacted with Tornado Cash cannot interact with your protocol anymore. Then it would be dodged, basically. So it's very flexible when it comes to the rules that you specify. So for example, whether it engaged with mixers, flagged by OFAC, has it done a KYC with centralized exchanges? Because if it has done ever before, then if there is a problem in the future, you can track it back to the centralized exchange again, right? And you can basically specify the conditions. And the beauty over here is, remember that crypto is across the globe, right? So you can adjust it depending on which country it regards to, right? So for example, for American users, you can have a different one. And then for, let's say, Dubai users, that is a bit less strict, you can have totally different conditions. How does it look in practice? So if you're a user, you can have like various levels of verification. And depending on what you want to do with the protocol, you might be allowed only when you go through of them. So for example, you can do transaction X only if you've done the KYC with decentralized exchanges. You can do transaction Z with another rule. So it's truly customizable depending on your needs. In the future, you can also add like broader business logic. So has the user done X number of transactions within your protocol? So then he's eligible for like a super secret feature or whatever. Or is it flagged as a bot, maybe in any database that you can crawl through? So it truly unbundles a lot of opportunities to do the blocking, like whitelisting and blacklisting on a smart contract level. This is just up to the business use cases, what we are going to implement it for, right? So why KYD? Know Your Degen. So first, refusing on-chain third-party data. It's flexible when it comes to defining rules. How long it takes, maybe again, to do this verification. Right now, it's about a couple of seconds, sometimes 20 seconds, but it really depends how we are going to structure it on a production environment, and we can probably go as quick as 2-3 seconds, right? So it doesn't necessarily break the user experience because the user is used to waiting like 2-3 seconds. Yeah, real-time updates of the information, so it's not like we have just stagnant database towards which we are calling. Like, for example, if we cooperate with Chainalysis or any other forensic company, we can get the updates in real time. So it crawls as it goes. And it's invisible for end users, so you know, like no one wants to have a different user experience because of any like KYC implemented over there, so it's very lightweight in that way. Here I'm going to show you a video how it works in practice. So we have, okay, this is database from Coinbase with all the addresses that have ever done KYC with Coinbase. Now I connect the wallet, you can see my address, you can see the integrated contract, and I'm verifying level 3 of the allowance, whether I can interact with the smart contract. On the MetaMask, you could see on the hex that there is this additional payload. Right now, transaction is being sent and verified. If you go to the Explorer, you can truly like see the function like verify address mint token. And this mint token, so once you've gone through a specific KYD level, then you can mint the token and interact within, let's say, this level of allowance. Or you can specify that you have to go through it every time. Now let's do it again for another address with level 1 KYC. I cannot stop it, I think. Okay, but there is like any transaction from Coinbase, all transactions from Coinbase, or at least one transaction with 100 USD from Coinbase. So you can see like there are various rules upon which the verification happens. Now verifying and minting the token, and this time it turns out that, yeah, it takes, as I said, sometimes up to 20 seconds because it's still like the first implementation. Yeah, so sorry, your address doesn't have required KYD level. So it basically blocks the transaction to go through and interact with the protocol itself. What's next for the Know Your DeFi Oracle? Basically, we are happy to run a pilot with your dApp or institution. So especially if KYC and like regulations is a big struggle for your dApp or a company, I'm happy to chat about your use case. And right now we are rolling out some small batch of test use cases, one of which is, for example, Signum Bank in Switzerland, but also like I have 2 other partners that we are running like closed alphas, and then we'll gather the feedback and try to make next steps regarding this product. I have 3 minutes, 26 seconds left, so I suppose I managed to squeeze it within the 20 minutes. So maybe we have some time for questions. Yeah, we do, I suppose. Here we go.
Hello. 2 questions. First question is, what is the gas overhead of the normal transaction? And the second question is, why do you not using signed messages and transaction simulation, for example? Because in that case, I signed the transaction, send the transaction, spend some gas for this, and after that, the transaction is refused.
Okay, so first, when it comes to gas consumption, it really depends on the structure of the package that we have. So, you know, like this cold data, you pay per every byte, right? So depending how big is this pack, how basically we receive it, let's say from chain analysis, the gas consumption is going to depend on that. But in our model where we got a database from Coinbase, right, and we run it on our servers, it wasn't like a big overhead. I mean, it was still acceptable because we know that gas is very important, especially like on layer 2 networks, it was like marginal. And when it comes to the second question, I think it's mainly about creating a viable proof of concept. Like that kind of considerations when you already sit down with the protocol and try to make the de facto implementation, we can also like have a look into that. So it's not like it's an ultimate flow. It's rather like it's just a showcasing that we can deliver it, but then ironing out the details, we can go also that way.
Any more questions?
Maybe to add to that, like with the price feeds packages, it's on Arbitrum it's 0.00 something, like no cents. And on Ethereum, usually it's like 0.10, so like 10 cents additional to the transaction, which on Ethereum is not that bad usually.
Hi. Where do you source the data for various filters?
For the KYD.
Yeah.
Yeah. So here again, like for the first implementation, Coinbase Ventures is one of our investors, so they just allowed us access to the whole like transaction database that the addresses database that they have. But right now, for example, with Signum, they give us the because we are not forensic company, we are infrastructure company. So we usually will work with the provider that will like the client that will let us know what are the requirements, and we are going to adjust the data source to the specific use case. So we already have established communication with chain analysis, Elliptic and other like forensic companies, so we can search from that. We can also get it from on-chain, so we already have a database from all the addresses that interacted with Tornado Cash. So if you want to do the first implementation, like blocking Tornado Cash users, this would be a very low-hanging fruit for us. So it's just the matter of the use case. We can truly get it from various sources. Okay, thank you.